if you're learning this in the middle, we're kind of in the middle. All right. So,
Can we at least show them that?
sorry. Sebastian recommends I show you the formula. There it is, right here. Get that down. This is important here. Can they see me tapping this? This here. This is important. Bet you wish you were in class. We're having a good time. This is also important. You might write this down in your notes. Okay, pause it. All right, go. Here we go. All right, here we go. Now, there we go. Du theta. Here's the derivative. What's the derivative on 2 sine theta plus sine 2 theta? 2 cosine theta plus 2 cosine 2 theta. And the denominator derivative? Negative 2 sine theta. Minus 4. I see what you're saying. I just wasn't there yet. Minus 4 cosine theta sine theta. In all these cases, I want to evaluate at pi over 2. You can see that the derivative is all functions of theta, so they usually say it's some theta value. Although I guess they could say it's x this or y that. It's usually they give you the theta. Okay, so the numerator derivative, what does it come out to be? That's not what I expected. Oh, no, it doesn't. 0 plus 2 times negative 1, so negative 2 in the numerator, yeah? The denominator is negative 2 and 0. So 1. Does that about jive with my picture of positive slope? Yeah, that seems right. So we know the y-intercept, I guess, is 2. So let's go slope-intercept form. What is it? Y equals 1x plus 2. Okay? There's our tangent line. Boom. Now, that's no calculator. Let's try one with the calculator. What'd you get out your calculator? Does anybody have an 84? So sad. The Inspire will not do this derivative for you. You have to do a ton of work. 84. No problem. Haha. Calculator. Okay. So, here you go. Would you get that? Would you get that equation into your calculator, please?
Was it this one?
You're getting this calculator equation into your calculator. In polar mode. Do you want to put your calculator in polar mode? Put your calculator not in polar mode. And then try to find the point in the slope in polar mode.
Mine does not look like that.
It doesn't? Did mine?
No, mine looks like yours.
Oh.
Mine looks like you and That's so weird. There's only one equation.
It's getting a little heated up.
I just think I should see my previous one. Okay. I just wanted to lose my previous work. I didn't want you to see it. Okay, what?
Is it -2.93?
How did you find that?
I did it in my calculator.
Oh.
So if you just take menu, calculus, wherever we're looking for it, that's x equals 1. R1
I feel like it's
Okay. So that is changing our perspective. I don't think so. I don't think that's going to work, but we'll see. Okay? If that works, then I'll say yes, but I don't think it does. All right, so here we go. To find a tangent line, we need a point. What is the x? What is the x? Don't have it. How do we find x in a polar kind of way? R cosine theta at 1. That then by calculator is going to be something like R is in your calculator stored at 1 times cosine of 1, and x is negative 0.622. Do you agree? Okay. Negative 0.622. Y is r sine theta, so do that at 1. Boom, 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 boom. Sine 1. Did you get negative 0.968 or 969, whichever you prefer? Negative 0.969. I don't know why I put parentheses around that. Okay? Do we all agree on the point?
Yeah. Why
Oh.
did you do that?
Say again. Oh, because we're going to do a tangent line, so we need the point of tangency in x and y, not r and theta. Do you agree?
Wait, how do we do this again? Like,
So first of all, do you agree that x is always r cosine theta, and y is always r sine theta? So I am just calling up the r as I've defined it, which is this big mess, and saying at 1 times cosine at 1. That's the x. When I do that, I'm finding the x as a point of tangency to the curve. With me? Okay. So, why did the same? With me?
yeah.
Okay. So, for the slope, we want dy dx, yeah?
Yeah.
So we want dy d theta at 1 over dx d theta at 1. So I need to take the numerical derivative of r sine theta at 1 and the numerical derivative of r cosine theta at 1. And that'll be a big mess, but let's see what we get. Okay, so parentheses, derivative. Wait. I took menu calculus, and I'm going theta.
Okay.
Theta is in the pi submenu. Okay? The value of theta is 1. First derivative. Now, I want the derivative of r of theta at 1 times sine theta. Did I hit a thing?
put anything in for the value?
I said, yeah, the value is theta of 1. Okay? Do you agree? Okay, now, whether you do that first and store it or then just roll into the next, I then want to divide that by dx d theta, which is calculus derivative theta at 1. The derivative of r of theta times cosine of theta, and I think that's all. Did you get 5.0125?
So you have to do,
Okay.
like, can you do Harvey?
You're
serious.
I rounded. I should be using. To me, these are rounded, so they should be approximate. Sure. Okay, so we have something like y plus 0.969 equals 5.012 x plus 0.622. Do we agree? Yes? Okay. Any questions? All right then. That's done. Questions on, actually, on the homework, the front side. My multiple choice answers are as such. C, B, B, A. Okay. Yeah, it should be there. I'll fix it, let me know, and I'll get you on it. All right, the back side. You have slopes of steep negative, flatter negative, flat. Flat. 1, 2, 2, 3, 4. 4, 5, 6. Okay. The particular solution, if it goes through 1, 1, it would take you down this way. But along what line are the slopes flat? Where on the coordinate plane are all slopes flat? Y equals negative 2x. Along y equals negative 2x, the slopes would always be flat. And so somewhere in here, it must go flat. On this side of that, the slopes are most definitely negative, so it should be negative, flattish, positive, it should look like that, something like that.
Wait,
So
why does it go flat like down there?
anywhere y equals negative 2x, anywhere 2x plus y is 0, this derivative is 0, so the slope is flat. Well, that would mean anywhere, at any point where y is negative 2 times the x, it would have to be flat. So along this, kind of in this region, it's got to be flat anywhere it gets to that spot. Okay. Yes?
Yeah, because when it
Wouldn't it curve like this? Maybe. Maybe. I don't know, maybe. It would mark you off for that. You would have to go out there and investigate. That's true, you're probably right. Okay. This, for B, did you get a Euler of 1.65 with appropriate work? With good work. I told you on the front I would allow you to cut corners in multiple choice, but on the back it should be good Euler work. The C was hard. B is negative 2. We can do that together. Okay. B is negative 2. We'll come back to that in a second. That's definite. Okay. For C, D rather, excuse me. D, they want, how do you determine if something has a local maximum in? What are the two calculus ways? Okay, that's what you do, but what's it called? That's called the first derivative test. Another is the second derivative test. What kind of test should you use if your derivative is both x and y? Second derivative test. So you need your second derivative. And I think I had it there as a local min, yes. The derivative is 0 and the second derivative is positive is how you would justify that. You cannot just say one or the other. It needs both pieces of evidence. Understood? I'll be happy to go back over that. Actually answering, I don't know if you, this is often a last point. Make sure you answer both questions. Does the graph of f have a local extrema? Okay.
Yes.
Yes. Okay, people think it goes without saying, but yeah, it does have local extrema. It's a local min because blah, 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 blah. All right. What about A? What was the approach to 6, I guess? A? A hospital. The hospital. You would have to say that either the limit of f of x plus 1 or just f of x plus 1 goes to 0. sine of x goes to 0. So by L'Hopital, this limit is equivalent to the limit of the derivatives, f prime over cosine of x, which is 2. Okay. The estimate, we had a ton of disagreement on B in the last class. My answer is negative 11 over 32. Okay, I guess what was wrong with those numbers? Okay. And C, y is 1 over negative x squared minus 2x minus 1. C on the previous? Sure. Okay, so this kind of differential equation question is one of the harder ones for students. It has really low averages. It only happens about 1 every 4 or 5 years. So, ballpark. It's once you get it's not something you'll figure out on the test if you haven't seen it before. So I want you to have seen it at least twice. You've seen it once already. So here goes. The point, though, first of all, overall, is this. This is really just a huge bunch of potential graphs, right? And depending on where you go through, it could look like this, or this, or this. Over here, it might look like this. It could look a lot of different shapes. What they're really saying in this question is it's possible that there's a really clean, just linear solution to this equation. Where is it? And in essence, the B is the where is that line? So it's a clean line. All right. You have to kind of draw little bits and pieces and put them together. So tell me, focus on the slope. Tell me one thing you know about the slope. It's 2x plus y. That's a fact you must know. Now, the next thing is, if this is going to be a solution, what else do you know about dy dx? It has to also be negative 2 in this case. What else? Or what now? What's that? Yeah, okay, so you really have two things to do. You need to say, first of all, that these must be the same. And you could do these in either order. They have to be the same if they're both dy dx, right? Yeah. But that doesn't have b in it.
So now
Yeah, they say that y is negative 2x plus b. So b must be. Okay. D. D. Okay. I know that dy dx at 1, negative 2 is 2 minus 2 or 0. Is that enough to say, yes, there's an extreme?
No.
No, that just means the graph goes flat, but it could be this kind of deal, trick you kind of thing, all right?
Yeah.
So to really talk extrema, we either have to do a, does it change slope sign there, or something else. Now, does it change sign there is stinking hard to answer because it's a two-variable derivative. And you'd have to say, well, if x changes this way and y changes that way, it's this crazy kind of sign test. You just don't do a sign test on a case like that. You do a second derivative. So if I take the derivative of the derivative, what was it, 2x plus y, or differentiate with respect to x, then the left side is the second derivative, obviously, and the right side is 2 plus dy dx. Remember, you're differentiating with respect to x, so the derivative of y is dy dx. That is equivalent to 2 plus 2x plus y.
If you are currently in JHS, you do not need to do another application. Discard the one you got today.
Hey, did you get a 2 for the second derivative at the point?
Yeah.
What is going on there if the derivative is 0 and the second derivative is positive? Draw me a little doodle.
It's like an up smiley face.
It's an up smiley face. Okay. I was thinking you had a horizontal tangent with concave up, but sure, an up smiley face is okay too. Okay? So is that a min or a max? That's a min. To cite the correct conclusion, you'd say you do have an extreme out. We do have an extreme out. Because dy dx equals 0 and the second derivative is positive at 1, negative 2, there is a local min there. Or relative min, obviously you're useful with these two words. Okay, other questions on this? 4. 4.
Okay.
Did I have a multiple? Didn't I paste in the multiple choice? Guess I didn't paste in the multiple choice. Hang on just a minute. 4. Boom. Okay. Here we go. Shucks. Make this a little bigger. Okie dokie. So we are starting at 0.6. My initial. Oh no, we're starting at. Where are we starting? Negative. Oh, we're starting at -1, right? And we're going to 0.6 in
My brain doesn't work. I didn't even know.
2 steps. So we're going to go to -0.2
What was that?
and then up to 0.6. So is that cool so far?
Oh, okay. What did I do?
I'm not sure. Did you have your F step?
Ratio or Boston?
I just don't think I kept, I think I just went in one iteration. I just forgot to keep going.
Yeah, I would guarantee that on the multiple choices they always have an intermediate answer.
Yeah, that's
All right. Anything else? All righty then.
It's like math. Oh, okay.